Alright, welcome to today's lesson on basic probability. From here we'll accelerate into proper Year 11 stuff. This is just a lesson about a few refresher things. So there's a few words you need to remember and recognise. We'll start with sample space. Sample space is shown using the symbol, well there's a few symbols it's shown using. The one the book uses this time is epsilon, looks like a backwards 3. I haven't drawn it very well, but you'll get the idea. Sample space is just all results, all possible results in an experiment. Alright, so remember that when it asks you to list sample space, it's all possible results. If you have multiple results, we don't need to list them more than once, but order is important. Alright, the second thing is we could have a random experiment. This is just the thing that we're testing. Alright, inside that random experiment we could be interested in one event happening. So if we're flipping a coin, we could be interested in the probability of a head or the probability of a tail. Each of those is called an event. Then to look for those events, we would perform a trial. And a trial is one, I'll call it iteration of the experiment. So if we're flipping a coin, the trial might be flipping the coin. If we're pulling ping pong balls out of a bag, it might be one pulling a ball out of the bag and looking at its colour or something like that. One iteration of the experiment in which we look for a certain event inside the experiment. Alright, so those are some keywords to look at and remember. Now we're going to have a look at a few questions. This one here is the first one. It says a bag contains 7 marbles numbered from 1 to 7 and a marble is withdrawn. Give the sample space. So the sample space is all possible outcomes. So we could get a 1, a 2, a 3, 4, 5, 6, or 7, like so. And we put it in those curly brackets to show that it's a sample space. All right, it's a set of numbers that are possible outcomes. Okay. Second one says list the outcomes of the event a marble with an odd number is withdrawn. So the sample space in this one would be only odd numbers. And we'd stop there because the highest number is 7. All right. Now, if we had to answer questions around this, let's say we're looking for a particular event. Let's say we're looking for an event of an odd number. We want to know the chances. We would go, there are 4 odd numbers out of a possible 7. So the chance of having an odd number out is 4/7. Let's say we were looking for an even number. We'd say, what are the chances of finding an even one? There are 2, 4, 6. There are 3 even numbers out of a possible 7. So we have this. Now what we're looking at here is just the events sample space over the total sample space, or the number of odd out of the number total. All right. So this is another way of thinking about probability. This test here, random experiment may result in a 1, 2, 3, or 4. We don't know what it is. We know that those are the outcomes. If the chance of a 1 is 1 in 13, if the chance of a 2 is 2 in 13, the chance of a 3 is 3 in 13, what is the chance of a 4? Now we're going to think about this logically. If I do an experiment, something has to happen, doesn't it? I have to either pull a 1, a 2, a 3, or a 4 out. And that means that at the end of the day, the total probability has to equal 1. So if I add up the chances of these 3, I get 1 plus 2 plus 3 is 6 13s. What's left over to make it up to 1 is 7 13s. That 7 13s must be the chance of getting the last result. So the PR of a 4 is 7 13s. This idea is a relationship that we call, or we show with this thing here. The chance of not A equals 1 minus the chance of A. So if I looked here, I'd say, what are the chances of not a 1, 2, or 3? It would equal the 1 minus the chance of a 1, a 2, or a 3. We knew that if it was not 1, 2, or 3, it was a 4. So the chance of 4 is 1 minus the chance of 1, 2, or 3, which we knew. All right, so there's a few rules we have to remember with probability. There is the sample space is all possible outcomes. An event is a subset of, or it's what we're looking for. We have probability of something happen has to be greater than or equal to 0. We can't have less than 0. The sum of all the probabilities must be equal to 1. So something must happen at the end of the day. We can also flip things around like we just did and look at the chances of not this happening by subtracting this happening from 1, which tells us the special word is complementary events. You might remember that word from complementary angles, where they have to add to make 90 degrees. And this one they add to make 1, or 1 whole. All right. The other thing to remember is that probability of A is just the number of outcomes of A divided by the total number of outcomes, shown like this. All right, so this is all just basic probability stuff we might remember, might not, but there's a few questions to test our understanding.